In section 9.4, we used factoring to solve quadratic equations. This video will work homework problem number 34, found on page 571 of your text. The learning target for this section is I can solve quadratic equations by factoring. Remember that there are multiple ways to solve quadratic equations. The first way that we have discussed is solving a quadratic equation by graphing. We have also learned to solve quadratic equations by taking square roots. In this section, we will learn a third method for solving quadratic equations, and that is factoring. Now remember that only some quadratic equations will be able to be solved using this method. And the specific method that we will apply is called the zero product property. So in other words, what we're going to do is we're going to write the quadratic equation in standard form, and then we're going to factor it. And after we factor it, we can apply the zero product property. Now the zero product property states that whenever you're multiplying two factors, that the only way to have a product of zero is if one of the two factors is zero. For instance, 3 times 0 is 0 because one of the two factors is 0. Likewise, 0 times negative 4 is 0 because the first factor is 0. This idea, a zero product property, enables us to solve quadratic equations that are in factored form. And we're going to use this method to solve the following problem. Okay, so this is problem number 34. You have a rectangular koi pond that measures 6 feet by 8 feet. You have enough concrete to cover 72 square feet for a walkway, as shown in the diagram. What should the width of the walkway be? So let's look at what we know in the problem. Here's what we know. We know that the pond is 6 feet by 8 feet. Now, if you think about it, this isn't a problem that involves area. So whenever we have a rectangle, we know that area is found by multiplying length to width. So since 6 times 8 is 48, that tells us that the pond has an area of 48 square feet. So when you look at this problem and you're looking at the pond, keep in mind that the area is 48 square feet. That's something that we know. The number wasn't given to us directly, but we know that that is true because of the dimensions of the pond. We also know that we have enough concrete to cover 72 square feet. Now, think about what that represents. We're going to use concrete for the walkway. Here's the walkway right here. So that means that we have enough concrete to cover only the walkway, not the pool. So when you look at the entire diagram, we now know the area for the entire pond plus walkway. In order to get the total area, we know that we would take 48 square feet and add that to 72 square feet because 48 represents the pond and 72 represents the walkway. So sometimes when you're looking at a problem, you not only want to figure out what the problem tells you directly, but also what the problem tells you indirectly. And all of these numbers can be found by just looking at the particular diagram. Now, we don't know yet whether we need all of these, but chances are we probably do. Now, what do we need to know? What we need to know is what the question is asking us to find, the width of the walkway. Notice also that in this problem, the variable is already defined for us. So if you were to write a let statement, we would say that let x equal the width of the walkway. So when we write an equation, anywhere we see x, x represents the width of the walkway. Okay, now the two questions that follow are designed to help us solve the problem. How can you write the outer dimensions of the walkway? So the outer dimensions would be this by this. So length times width, so we'll call this the length and this is the width. And how would we write those? Well, the length is 8 feet for the pond, and then x here and x here. So that would be 8 plus 2x. What about the width? The width is 6 feet here, plus x up here, and x down here. So that's going to be 6 plus 2x. So those two dimensions are going to help us to solve the problem. Okay? Then the second question that it asks us is, how can you represent the total area of the walkway and pond in two ways? Well, the first way I found here. I can represent the total area by taking 48 square feet and adding it to 72 square feet. That's a total of 120 square feet. So that's one way. But a second way I could represent the area would be length times width. So area is equal to length times width, and I just wrote the length as 8 plus 2x, and I wrote the width as 6 plus 2x. So that's a second way of representing the area. Well, if the area is 120 square feet, and the area is also 8 plus 2x times 6 plus 2x, to write an equation that could be used to solve for the width of the walkway, we could just set those two quantities equal to each other. And that's exactly what I'm going to do. Okay, so here's the equation. 8 plus 2x times 6 plus 2x is equal to 120. And there's my equation. Okay, now to solve this, we have to get this into standard form. This is going to be a quadratic. Watch how it comes out as a quadratic after I multiply. To multiply, I'm going to use the FOIL method. So, first two terms, 8 times 6 is 48, plus outer terms would be 8 times 2x, that's 16x, plus inner terms is 2x times 6, that's 12x, plus 2x times 2x is 4x squared. Now that is still equal to 120. Okay, let's clean this up a little bit. I'm going to write the 4x squared term first to start getting it into standard form. I'm going to combine my two middle terms here. 16x plus 12x is 28x. And then what I'm going to do is put the 48 last, and it's still equal to 120. Okay. Now, I still don't have this in standard form because if you look on the end here, there's a 120. And to get this in standard form, I need this to be 0. So what I'm going to do is subtract 120 from both sides to put this in standard form. And that would give me 4x squared plus 28x minus 72 is equal to 0. Now I have a quadratic in standard form. Remember that anytime you're solving quadratic equations, your first step is to write the quadratic equation into standard form. After that, you can start manipulating it in whatever way that you choose to solve it. Because remember, ultimately we're going to have 5 different ways that we're going to be able to solve these. Right now we're on our third method. So I'm going to factor this because that's what this whole whole lesson rather is about. First step to factoring is always to pull out the greatest common factor. 4, 28, and 72 can all be divided by 4. So I'm going to pull out a common factor of 4. And 28 divided by 4 is 7. And 72 divided by 4 is 18. Okay. I'm going to leave the 4 out front and I'm going to factor this trinomial. Now remember, when you factor a trinomial, it's x times x, and then I'm looking for two numbers that multiply to give me negative 18, but add to give me positive 7. So the two numbers in question, well, let's write down our factors of 18 first. So 1 times 18, and 2 times 9, 3 times 6. And we need one to be positive and one to be negative because it's a negative 18. And I need to be able to add these together to get 7. So what I'm going to use then is the 2 and the 9. And I want a positive 7, so I'm going to place the 9 here and put the 2 here. And negative 2 plus 9 is positive 7. Okay, so now what I'm going to do is apply the zero product property. So I'm going to split all the factors. There's 3 of them. And I'm going to set each factor equal to 0. So 4 equals 0. Well, that's not a true statement. So that doesn't even count. So this guy, we don't even have to really worry about. I'm going to set x minus 2 equal to 0 and solve for x. So if I add 2 to both sides, x would equal 2. Then I'm going to set x plus 9 equal to 0. And when I solve for x, I subtract 9 from both sides, so x equals negative 9. Okay, now keep in mind what the original problem was about. The original problem was about a pool surrounded by a concrete walkway. And what we were looking for was the width. So when you're solving these problems, you have to keep in mind that your answer, if you come up with a negative x value, that's probably not going to be a valid solution. So x equals negative 9 is not, because our walkway here cannot have a value of negative 9. However, the walkway could have a value of 2. And so basically what we're saying is that the width of the walkway is 2 feet. Okay, write your answer as a complete statement, and that looks really good.